Hello friends, and welcome to the last section of Chapter 1, Direct Variation. So, let's just define direct variation just right away. Direct variation. Okay, so a number varies directly I can do this, with another number if they qualify as being proportional. Okay, so we've talked about proportionality a lot. And so if we have two numbers that are proportional, we can also say they vary directly or have direct variation. So to remind you what we need for proportional, on a graph, two things, right? It has to be a straight line and go through the point 0, 0. Okay, in a chart, constant rate of change or basically all of the fractions reduced down to the same number. And also you want to work backwards if needs be. To verify 0, 0 works. Okay, because we got to make sure that it's going through 0. Otherwise, we can have a straight line and a constant rate of change, but it doesn't count as direct variation if it doesn't go through the point 0, 0. Okay, so remember yesterday or last lesson, I was talking about, we talked about slope. So let's remember what slope is, because that really is our measure of our constant rate of change. So remember, it's the change in y over the change in x, or the rise over the run. Okay, both very important ways to think about it. And so this is our constant rate of change. Okay, and then we can also call it, starting today, we're actually going to call, instead of it being slope, for today we're going to call it K, which is the constant of proportionality. Because I have no idea why. This is a place where the book and I don't necessarily agree. But here we are. So again, it's all kind of different names for the very same thing. So yesterday we were looking at equations y equals mx, because the plus b is 0, so we don't write it. Today it's going to be y equals kx. So if they ask what the constant of proportionality is, they're looking for the slope or the constant rate of change, which, if it's proportional, will also be the unit rate. They're all basically the same thing. We can do this, though. It's fine. We got this, right? Right. Okay, so let's just look at some practice problems. So this one, I'm just going to go right into the book for a minute. The height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. So the inches goes on top. Inches goes on top, right? Because that's the y over minutes, which is time. So we can either, because it goes through 0, let's just verify. It looks like we're going up 2 inches for every 5 inches we go over. Does that work again? Up 2, so we go from 2 to 4, and then add another 5. Yep. So it looks like we're going up 2 for every 5 inches. Excuse me, 2 inches for every 5 minutes. So that would be our slope, or constant of proportionality, or constant rate of change. It's not a unit rate because one is involved, but other than that, it's like covers all of the things. Right, so it's all the different math. But the 2/5 totally works. Okay? 2 minutes after a diver enters the water, he has descended 32 feet. So 2 minutes to 52 feet. After 5 minutes, he's descended 130 feet. At what rate is the scuba diver descending? So basically, we just need to do this division to find out what that constant rate is. And again, we're going to do 52 over 2 and 130 over 5. And let's see if it comes out to be the same thing. It's very exciting. Okay, so 52 divided by 2 gives 26. And let's just verify 130 divided by 5 is also 26. Okay, so he's going down 26 feet per minute. Constant rate of change, slope, constant of proportionality, all those things. Okay, so the equation y equals 10x represents the amount of money y Hurley earns for x hours of work. Identify the constant of proportionality. That's just going to be that number written next to x, right? But then explains what it means. So the constant of proportionality is our slope. So that means for every hour that he works, we're going to multiply it by 10 to find out how much he makes. So the constant of proportionality, so Hurley earns $10 for every hour that he works. Okay, so I told you these equations were coming. The distance y traveled in miles by the Ching family in x hours is represented by this equation. So again, distance equals rate times time. And that's a formula you're actually going to use in science quite a bit. Distance equals rate times time. Identify the constant of proportionality. That's just the number that's next to x. And then explain what it represents. That's the rate, that's how fast we're going. So it's 55 miles per hour, if that's miles an hour. So yep, 55 miles an hour is how fast they're going. Ta-da! See, it's not too tough. Now, like this is saying, not all situations are with a constant rate of change are proportional. So you can have straight lines that aren't proportional. Proportional, they have to go through the point 0, 0. So in this instance, just looking at the graph, we know right away not proportional because it doesn't go through 0. Okay, graphing is really the easiest way to see that. You can also look each of the fractions. So 1/11th, then it would have to be 2 22nds or 3 33rds. So these don't reduce down to the same fraction either. So two shots against it for that. And remember, my clue for that is the plus an extra something. When there's plus an extra something, that means that b, that y-intercept, is not going to be through 0. So if we look at this, 2 pounds of cheese costs $8.40. That one is going to be a constant because it doesn't give us different numbers. Alrighty. So the last couple problems I want to show you how to work are ones that are going to be on the back side. And they're going to look something like this. So it's going to say find x when y equals 14. Wow, that was weird. 2 y's. Find x when y equals 14 if y equals 7 when x equals 8. Okay, so we have to set up 2 fractions, and because we want them to be proportional, so we're assuming that we can use cross multiplying to solve for this. Okay, so the first one, we like to write it y over x, so I'm going to write this information is our complete fraction, right? And so I'm going to write the y over the x, so 7 over 8, and we're going to set that equal to y is 14, and we want to know what x is. Okay, this is one of those times we totally could cross multiply, do 8 times 14 and divide by 7, or we can just look at it and think, 2 times 7 gives us 14, so if we do 2 times 8, x we equal 16. But if we want to cross multiply, 8 times 14 is I turned it off. 8 times 14 is 112, and then we divide that by 7, should still come out to be 16, which it does. Ta-da! So setting it up is the difficult bit on this, I think. Let's try one more. Find y when x is 36 if y is 5 when x is 6. Okay, oh, this one's giving us an easy one that we're not actually going to have to cross multiply either. So let's take our complete sentence and write that as a fraction. So that's going to be 5/6, and we're going to set that open. We want to find y, which is on top, when x is 36. And again, looking at this, what times 6 gives us 36? That would be times 6, so we can do the same thing up here. So x should equal 30. But while we're here, let's practice our cross multiplying. So 5 times, well, I don't know what I was doing there. 5 times 36 is 180 divided by 6 does indeed come out to be 30. So it works both ways, okay? So if you have problems setting up the fractions on the last couple problems, just let me know. In fact, I think I might have done a couple of those are very similar to the problems that are actually in the book, okay? All right. Good luck with all of this stuff that basically means the same thing as everything else we've been talking about.